We bet that you and many of the other students in your class have already been in at least one research study. In fact, most of what we know about human behavior has probably come from studies of captive audiences of undergraduates. Okay, maybe that is a bit of an exaggeration, but it's close enough to the truth that it has been a criticism of research in basic and applied social sciences over the years, figure 4.1, and it has everything to do with the subject matter of this chapter, who participates in studies and why, a process that researchers call sampling. Figure 4.1. Would you say this sample is representative of college students? Universal the KOPAL collection. Would you say this sample is representative of college students? Sampling is the process of selecting units, most often people, groups, and organizations, but sometimes texts like diaries, internet discussion boards and blogs, or even graphic images from a population of interest, so that by studying the sample you can generalize your results to the population from which the units were chosen. As will become clearer later in this chapter, the nature of your research question has important implications for the type of sampling design that you chose. More descriptive and exploratory studies generally rely on a small number of cases that can be studied intensively, i.e., up close and personal. In contrast, some studies aim for results that are very general and that represent populations, like large surveys or studies that are used to test drugs for deadly diseases, so they include larger samples of carefully chosen participants. And you have probably heard of a census, like the one that the US government conducts every 10 years. A census study doesn't pick a sample from the population. It attempts to include the whole population. Figure 4.2. Figure 4.2. The US Census attempts to measure the entire population. Row to Sydney photo edit. The US Census attempts to measure the entire population. There may be times you won't be concerned about generalizing. Maybe you're evaluating a program in a local agency and don't care whether the program would work with other people in other places and at other times. In that case, sampling and generalizing might not be of interest. In fact, in this case your study would not even be considered research by the federal government or your local IRB, precisely because you are not looking for generalizable knowledge. Or, you might be conducting a case study in which you're primarily interested in a detailed look at one specific case, be it a person, program, organization, or event. In addition, many, if not most, qualitative studies are focused on capturing the essence of a particular phenomenon in a particular context rather than on comparisons to other people or situations. In this chapter, you will see that there are two major approaches to identifying a sample for a study. One is called probabilistic, because it is surprise, based on probability theory or random sampling. It is probably the best sampling approach when you are able to accomplish it. It can provide a credible and rigorous way to extend your conclusions beyond just the group you studied to the broader population you are interested in. However, as you'll see, it's not always possible to do a probability sample. There are a number of alternatives that are called non-probability sampling approaches, for situations when using a probability-based sampling is not feasible. We'll review examples of both kinds of sampling strategy. We'll also cover many of the key terms that researchers need to know too in order to critique or design a study, like population and sampling frame. And, along the way we'll discuss how researchers can make judgments about the quality of the sample using statistical concepts such as sampling distribution and sampling error. 4.2. Sampling terminology. As with anything else in life, you have to learn the language of an area if you're going to ever hope to navigate successfully. Here, we introduce several different terms for the major groups that are involved in the sampling process and discuss the role that each group plays in the logic of sampling. The group you wish to generalize to is called the population in your study. See figure 4.3. This is the group you would like to sample from because this is the group you ultimately want your results to be about. Let's imagine that you want to generalize to urban homeless males between the ages of 30 and 50 in the United States. If that is the population of interest, you are likely to have a hard time developing a reasonable sampling plan. You are probably not going to find an accurate listing of this population, and even if you did, you would almost certainly not be able to mount a national sample across hundreds of urban areas. So we can make a distinction between the population you would like to generalize to, and the population that is accessible to you. We'll call the former the theoretical population and the latter the accessible population. In this example, the accessible population might be homeless males between the ages of 30 and 50 in 6 selected urban areas across the United States. Figure 4.3. The different groups in the sampling model. The different groups in the sampling model. After you identify the theoretical and accessible populations, you have to do one more thing before you can actually draw a sample. Get a list of the members of the accessible population. Or, if you cannot get a complete listing of the accessible population, you have to spell out in detail the procedures you will follow to contact them, to assure representativeness. For example, when doing quota sampling of passers-by at the local mall for a short interview, you will not have a list of people in advance. In this case, the sampling frame is the population of people who pass by within the time frame of your study, and the rule S you use to decide whom to select. In either case, the listing of the accessible population from which you'll draw your sample is called the sampling frame. If you are doing a survey and selecting names from a directory of email addresses, the email address list would be your sampling frame. By the way, that wouldn't be a great way to sample because significant subportions of the population either don't have an email address or have changed it since the last directory was posted. The sample is the group of people you select to be in your study. Notice that we didn't say that the sample was the group of people who are actually in your study. You may not be able to contact or recruit all of the people you actually sample, or some could drop out over the course of the study. The group that actually completes your study is a subsample of the sample. It doesn't include non-respondents or dropouts. The problem of non-response and its effects on a study will be addressed in Chapter 8, Design, when discussing mortality threats to internal validity. At this point, you should appreciate that sampling is a difficult multi-step process and that you can go wrong in many places. In fact, as you move from each step to the next in identifying a sample, there is the possibility of introducing systematic error or bias. For instance, even if you are able to identify perfectly the population of interest, you may not have access to all of it. Even if you do, you may not have a complete and accurate sampling frame from which to select. And if that's not bad enough, you may not draw the sample correctly or accurately. And, even if you do, your participants may not all come and they may not all stay. Depressed yet? Sampling is a difficult business indeed. At times like this we are reminded of what Donald Campbell, a famous social scientist, used to say. We'll paraphrase here. Cousins to the amoeba, it's amazing that we know anything at all. Well, one difference between the amoeba and humans is that we have statistics and they don't. Let's hope that's not the primary difference. Once we get over our envy of our cousins' stat-free single-cell life, we can put statistics to work in making our research better. 4.3. External validity. When we conduct research, we are often interested in reaching conclusions not just about our sample and the time and place where we conducted our study. We're often interested in making some conclusions that are broader than that, by concluding what is likely to happen with other people at other times and in other places than just those represented by our sample. When we try to reach conclusions that extend beyond the sample in our study, we say that we are generalizing. Generalizing and generalizability are possible when a study has good evidence of external validity. This means you can confidently say that what you found in the study sample holds for the broader population, that is, it appears to be generally true. In other words, external validity is the degree to which the conclusions in your study would hold for other persons in other places and at other times. Our best chance of obtaining this kind of evidence of external validity is if we have a representative sample. The best chance of having a representative sample is if it is randomly selected so that every member of the population has an equal chance of participating. And as you might imagine, a truly random sample depends on being able to obtain a list of every member of the population. In reality, the available sampling frame, the list of accessible members of a population, may or may not include every member. Ultimately, the idea of external validity should guide our selection of sampling. 4.38. Two major approaches to external validity in sampling. Research uses two major approaches to gather evidence to support generalizations. We'll call the first approach the sampling model. In the sampling model, you start by identifying the population you would like to generalize to. See figure 4.4. Then, You draw a representative sample from that population and conduct your research with the sample. Finally, because the sample is representative of the population, you can automatically generalize your results back to the population. Figure 4.4 details. The sampling model for external validity. The researcher draws a sample for a study from a defined population to generalize the results to the population. The sampling model for external validity. The researcher draws a sample for a study from a defined population to generalize the results to the population. This sounds simple enough, but there are several ways it can become difficult. First, at the time of your study, you might not know what part of the population you will ultimately want to generalize to. Second, you may not be able to draw a fair or representative sample easily. Third, it's impossible to sample across all times that you might like to generalize to, such as next year. Researchers who study real people in real-life settings deal with these issues frequently. Sometimes these problems are controllable, other times they are issues that must be worked around by making careful choices in design, measurement, and analysis. The second approach is called the Proximal Similarity Model, Campbell, 1986, see Figure 4.5. Proximal means nearby and similarity means, well, it means similarity. In the proximal similarity approach, you begin by thinking about different contexts you might want to generalize to, and which are more similar to your study and which are less so. For instance, you might imagine several settings, some having people who are more similar to the people in your sample, others having people who are less similar. This process also holds for times and places. Now picture this in terms of gradations of closeness to your study. Some combinations of people, places, and times are closer to those in your study, while others are more distant or less similar. The technical term for this idea is the gradient of similarity. There are some groups, for instance, who are more similar to your sample and would be closer along this gradient. Others would be less similar and further away along this imaginary gradient. Figure 4.5. The proximal similarity. similarity model for external validity. The proximal similarity model for external validity. For example, imagine that the sample in your study consisted of females between the ages of 18 and 22 in a small Midwestern college town. Who would likely be more similar to your sample, a group of females aged 18 to 22 from another Midwestern college town, or a group of females aged 18 to 22 from Paris? Most likely you would argue that the group from another small Midwestern college town are closer to your sample than the one from Paris. That is, you would be saying they are closer along a gradient of similarity. So, how do you use the idea of the gradient of similarity from the proximal similarity framework to generalize? Simple. You generalize the results of your study with greater confidence to other persons, places, or times that are more like, that is, more proximally similar to your study. Notice that here, you never generalize with certainty. Such generalizations are always a question of more or less similar, always a question of degree. Which approach is right? Which is better? There's no simple way to answer these questions. The sampling model is the more traditional and widely accepted of the two. If you are able to draw the sample well, a real challenge in many situations, and if you don't have too many subjects who don't respond, non-response is a growing problem in social research, then the sampling model makes sense. But the proximal similarity approach applies in any study as a guideline for thinking about external validity and generalizability. Even in situations where you aren't able to sample well from a population, or when you have many subjects who don't respond or who dropped out, you can always ask yourself what groups, places, and times are more or less similar to those in your study. Therefore, when it comes to external validity, you should always think in terms of proximal similarity, but use the sampling model to the extent it is practical. 4. 4. Sampling methods. Sampling methods can be classified into two broad categories: probability and non-probability sampling. While probability samples are selected in such a way that every member of the population has a known probability of being included in the sample, non-probability samples are selected on the basis of researcher judgment. Henry, 1990. As discussed previously, smaller descriptive studies, interviews, focus groups, case studies tend to utilize non-probability sampling methods, whereas larger surveys or controlled studies generally employ probability sampling techniques. That being said, it is important to keep an open mind when matching your research question with a particular sampling method. For instance, non-probability sampling methods tend to be used during the early stages of testing a new program, intervention, or treatment. In medical research, we conduct clinical trials in which a medication or other treatment is tested in multiple phases through a sequence of studies. The early phases are typically smaller studies looking for evidence that the treatment works without doing harm. Later phases include more tightly controlled studies that enable researchers to eliminate the possibility of a treatment result being due to something other than the treatment. Much like the phases in clinical trials, during the earlier stages of your research, you may be interested in an in-depth exploration of a social phenomenon, let's say, global warming, and in examining whether two variables, the potential cause and effect, for example, carbon emissions and surface temperatures, are at all related. Here, non-probability sampling methods are likely to be more suitable compared to probability sampling ones. Both types of methods, as well as their advantages and disadvantages, are discussed in detail below. 4.5. Non-probability sampling. The difference between non-probability and probability sampling is that non-probability sampling does not involve random selection and probability sampling does. Does that mean that non-probability samples aren't representative of the population? Not necessarily, but it does mean non-probability samples cannot depend upon the rationale of probability theory. At least, with a probabilistic sample, you know the odds or probability that you have represented the population well. You can estimate confidence intervals, CIs, for the statistic. There is an example of a confidence interval calculation in section 4.6c below. With non-probability samples, you may or may not represent the population well, and it will often be hard for you to know how well you've done so. In general, Researchers prefer probabilistic or random sampling methods over non-probabilistic ones and consider them to be more accurate and rigorous. In non-probability sampling, the sample is selected in such a way that the chance of each unit being selected is unknown. The selection of the subjects may be based on the researcher's experience, judgment, and access to potential participants. The trade-off in this type of sampling is an external validity. We won't have the same confidence about generalizing as we do when we can use probability sampling. In the following paragraphs, we will discuss a variety of non-probabilistic sampling techniques. Non-probability sampling methods are divided into two broad types, accidental or purposive. Most sampling methods are purposive in nature because the sampling problem is usually approached with a specific plan in mind. The most important distinctions among non-probability sampling methods are between the different types of purposive sampling approaches. 4.58 Accidental, haphazard, or convenient sampling. One of the most common methods of sampling goes under the various titles listed here: accidental, haphazard, or convenient. We would include in this category the traditional person-on-the-street interviews conducted frequently by television news programs to get a quick, non-representative reading of public opinion. We would also argue that the typical use of college students in much psychological research is primarily a matter of convenience. You don't really believe that psychologists use college students because they think they're representative of the population at large, do you? In clinical practice, you might use clients available to you as your sample. In many research contexts, you sample by asking for volunteers. In a rather unusual example of convenient sampling, MIT neuroscientist Pawan Sinha, who studies how the brain interprets what our eyes see, strapped a camera on his newborn son to record everything the baby looked at. The ethical debate notwithstanding, it is commonplace for many scientists, especially those who study child development, to use their own children as convenience research subjects. Belloc, 2009. Clearly, the problem with all these types of samples is that you have no evidence that they are representative of the populations you're interested in generalizing to, and in many cases, you would suspect that they are not. It is for this reason that convenience sampling is often used in pilot or feasibility studies, because it allows the researcher to obtain basic data that can be used subsequently to provide the justification for a larger study. 4.5b Purposive sampling. In purposive sampling, you sample with a purpose related to the kind of participant you're looking for. Usually you would be seeking one or more specific kinds of people or groups. For instance, have you ever run into people in a mall or on the street carrying clipboards and stopping various people and asking to interview them? Most likely, they are trying to get a purposive sample, and most likely, they are engaged in market or political research. They might be looking for Caucasian females between 30 to 40 years old. They size up the people passing by and stop people who look to be in that category and ask whether they will participate. One of the first things they're likely to do is verify that the respondent does in fact meet the criteria for being in the sample. Figure 4.6. Purposive sampling can be useful in situations where you need to reach a targeted sample quickly and where sampling for proportionality is not the primary concern. With a purposive sample, you are likely to get the opinions of your target population, but you are also likely to overrepresent subgroups in your population that are more readily accessible. Figure 4.6 details. Purposive sampling in a street survey. This researcher has found the kind of person she needs in her sample. We'll learn all about the techniques involved in conducting a good interview in Chapter 7 on survey research. Janine Weedle Photo Library May. Purposive sampling in a street survey. This researcher has found the kind of person she needs in her sample. We'll learn all about the techniques involved in conducting a good interview in Chapter 7 on survey research. All of the methods that follow can be considered subcategories of purposive sampling methods. You might sample for specific groups or types of people, as in modal instance, expert, or quota sampling. You might sample for diversity, as in heterogeneity sampling, or you might capitalize on informal social networks to identify specific respondents who are hard to locate otherwise, as in snowball sampling. In all of these methods, you know what you want. You are sampling with a purpose. 4.5c Modal instance sampling. In statistics, the mode is the most frequently occurring value in a distribution. In sampling, When you do a modal instance sample, you are sampling the most frequent case, or the typical case. Many informal public opinion polls, for instance, interview what they call a typical voter. For instance, you see this approach used all the time on evening news programs. The newscaster goes out and interviews a typical voter to get an idea of what voters are thinking about, figure 4.7. Or they interview a few people from a typical town, an example of modal sampling of towns rather than individuals. This sampling approach has a number of problems. First, how do you know what the typical or modal case is? You could say that the modal voter is a person of average age, educational level, and income in the population, but it's not clear that using the averages of these is the fairest. Consider the skewed distribution of income, for instance. Additionally, how do you know that those three variables, age, education, income, are the ones most relevant for classifying the typical voter? What if religion or ethnicity is an important determinant of voting decisions? Clearly, modal instance sampling is only sensible for informal sampling contexts. Figure 4.7. A typical couple that meets the study's definition in a modal instance sample. Copyright sign, iStockPhoto.com/Bonnie Jacobs. A typical couple that meets the study's definition in a modal instance sample. This method is also sometimes used in implementation research for planning new programs. For example, Aitken et al. 2004 utilized modal instance sampling to investigate knowledge, practices, and beliefs of all-terrain vehicle (ATV) users in order to develop effective educational strategies to promote safer ATV use. The study targeted typical adolescent ATV users who were males attending a rural community school and who were also enrolled in an agricultural or hunter education program. 4.5D. Expert sampling. Expert sampling involves assembling a sample of persons with known or demonstrable experience and expertise in some area. A common example of this type of sample is a panel of experts, figure 4.8. There are actually multiple reasons why you might do expert sampling. First, it is the best way to elicit the views of persons who have specific expertise. In such a case, it's clear why we consider expert sampling a subtype of purposive sampling. When someone says they used expert sampling in a study, all they are saying is that the specific purpose for their sampling was to identify experts. Second, you might use expert sampling to provide evidence for the validity of another sampling approach you've chosen. For instance, let's say you do modal instance sampling and are concerned that the criteria you use for defining the modal instance are subject to criticism. You might assemble an expert panel consisting of persons with acknowledged experience and insight into that field or topic and ask them to examine your modal definitions and comment on their appropriateness and validity. The advantage of doing this is that you aren't trying to defend your decisions on your own. You have some acknowledged experts to back you. Figure 4.8 details.
Welcome to the live, everybody. I'm taking some notes for next week, trying to work ahead a little bit. So hopefully you're learning something. I can't say if you're enjoying it, but you'll definitely learn something if you stay tuned to listen, and do consider subscribing to the channel and liking the video, guys.
Expert sampling is also used when there is insufficient data on a particular topic. In such cases, expert sampling procedures serve as a means to synthesize the limited available knowledge, which can then be used to inform policy development before conclusive scientific evidence becomes available. This method is routinely employed in many environmental impact studies. For instance, Nall et al. 2009 assembled a panel of clinicians, toxicologists, and epidemiologists to investigate the causal relationship between exposure to certain airborne pollutants and health outcomes, such as mortality and cardiovascular and respiratory hospital admissions. Despite the method's many advantages, it is important to keep in mind that even experts can be, and often are, biased and wrong. 4.5e. Quota sampling. In quota sampling, you select people non-randomly according to some fixed quota until you achieve a specific number of sample units for each subgroup of a population. There are several different types of quota sampling. In proportional quota sampling, you want to represent the major characteristics of the population by sampling a proportional amount of each. For instance, if you know the population is composed of 77% whites, 13% blacks, and 10% individuals from other races, and that you want a total sample size of 100, you should keep sampling until you get those percentages by race and then stop. Once you meet the quota of 77 white individuals, you wouldn't include any more whites even if legitimate respondents came along. You would do the same thing for blacks and other races. You would continue to sample until you reach your quota of 13 and 10 individuals, respectively. Of course, the hard part is figuring out the specific characteristics on which the quota will be based. Will you decide to use gender, age, education, race, religion, or countless other possible variables? Non-proportional quota sampling is less restrictive. In this method, you specify the minimum number of sample units you want in each category. Here, you're not concerned with having numbers that match the proportions in the population. Instead, you simply want to have enough to assure that you will be able to talk about even small groups in the population. This method is similar to stratified random sampling, section 47C below, in that it is typically used to assure that smaller groups are adequately represented in your sample. An issue with quota sampling, as with all non-probability sampling, is the potential overrepresentation of those individuals who are more convenient to reach. This can lead to biased results, because those who are accessible are also more likely to have socioeconomic characteristics that make them less representative of the entire population. This shortcoming was the reason why 1948 was the last presidential election in which the Gallup presidential poll prediction used the quota sampling method, Fishkin, 2006. In this case, even though quota sampling was designed to obtain opinion from the nation's demographic mirror, it led to faulty predictions because interviewers were free to survey whomever they wanted. In 1948, as now, Republicans were, on average, richer than Democrats, hence, they were more likely to have phones, live on good streets, and were thus more convenient to interview. An overrepresentation of Republicans in the Gallup poll led researchers to predict Thomas E. Dewey as the winner, when Harry Truman actually won the election in the presidency. (4.5f) Heterogeneity sampling. You sample for heterogeneity when you want to include all opinions or views, and you aren't concerned about representing these views proportionately. Another term for this is sampling for diversity. In many brainstorming or nominal group processes, you would use some form of heterogeneity sampling because your primary interest is in getting a broad spectrum of ideas, not identifying the average typical ones. In effect, what you would like to be sampling is not people, but ideas. You imagine that there's a population of all possible ideas relevant to some topic and that you want to sample this population, rather than the population of people who have the ideas. Clearly, to get all of the ideas, and especially the unusual ones, you have to include a broad and diverse range of participants. Figure 4.9. Heterogeneity sampling is, in this sense, almost the opposite of modal instance sampling. Figure 4.9. Sampling for heterogeneity is designed to get at the variability in a population. Michael B. Brown, Shutterstock.com. Sampling for heterogeneity is designed to get at the variability in a population. For example, Ma Jin, Adams, Henning, Pond and Smith, 2006, used heterogeneity sampling to study patient perceptions of acne causes. Researchers aim to increase the degree of representativeness by recruiting a wide variety of participants based on different individual-specific characteristics. These characteristics included severity of acne, care by general practitioner or specialist dermatologist, age, and gender. In effect, by introducing the desired level of variation, researchers were able to identify common themes across a broad and diverse range of acne beliefs. 4.5
Okay, guys, I'm gonna do the rest off camera. You can rewatch the video if you want to learn a little bit about advanced research methods within criminal justice graduate class. I'm paying a whole bunch of money for the class, so you got 20 minutes worth of free content. So hopefully you like the video, subscribe to the channel, and I'll be back later on when I'm eating my lunch/dinner.